Hey everybody, my name is Lindsay and I chose the prompt regarding balancing redox equations and how to pick half reactions. So just some key terms for studying's sake. A redox reaction involves changes in the oxidation numbers for one or more elements involved. The half reaction is part of the overall reaction that represents either oxidation or reduction. And two half reactions are necessary to describe a redox equation. So you have to have the reduction and the oxidation, the redox, both parts for it to be included in the redox umbrella. In this course, we used oil rig a lot. Oxidation is loss of electrons, reduction is gain of electrons. While I was self-studying and working through some YouTube videos for this module, I got a kick out of Leo the Lion says grr. Leo, lose electrons, which is oxidation, and grr, G-E-R, gain electrons, which is reduction. And you have to have balanced charges across the equation due to the law of conservation of charge. I know that was one of the things that kind of tripped me up originally, was where the electrons went, because in my head, it made more sense to add them to the side opposite of where they belonged. But the more I practiced, I heard on some video somewhere that losing electrons, you become more positive because electrons are negative, and then gaining electrons, you become more negative. So that really helped me with knowing which side of the equation to put the electrons when you're balancing. Picking out the half reaction is mainly just picking species that match. I didn't come with a slide deck or any of the equations, but you've seen them throughout the course. You just match them. So if you see iron on one side as a solid, and then iron 3 plus aqueous on the other side, that's going to be the first part of the half reaction. And it's just matching up the pieces that naturally fit together due to either gaining or losing electrons. The balancing section of the video is going to be a little heavy in the sense that it's just a lot of steps. So I've come with notes just because it's definitely not something that I have memorized yet, and I referenced this a lot during this module. But the first step for balancing the equation is to separate your equation into half reactions, and then you're going to use the half reaction method to balance the full equation. So once you have the two half reactions separated out, you're going to balance those with respect to all atoms except for oxygen and hydrogen. Those are addressed in the next couple of steps. So once just your straight across is balanced, for instance, if you had chlorine on one side and then Cl2 on the other, you would need two of the chlorines for them to be balanced, just like in Chem 1. Once everyone's balanced, you would move on to balancing for oxygen by adding H2O. And from what I could tell through my research, you do that because basically H2O only has one oxygen molecule, and that way it basically will balance across regardless. After you're done balancing for your oxygen, you would balance for the hydrogen that we've added to the equation by adding H2O, by adding H+, and then adding those electrons to each half reaction to balance the overall charge for the reaction. So while you're balancing, when you get to this step and you add your electrons, one of the half reaction will have them on the product side, one of the half reactions will have them on the reactant side. They'll never both be on one side. If you get to this point and realize that your electrons are both on one side, stop what you're doing and reassess, because it's going to be wrong. That tripped me up a lot during the very first few worksheets and problems that I worked on in this module specifically. After you've added electrons to each half reaction, you have to make sure everything matches. So if you've had to add 2 electrons to one half reaction but 3 to the other, you're going to have to find a common denominator between the two and multiply across to where they're the same. The goal is to get both electrons to equal so that you can cross them off in a following step. So finding that common denominator and getting everybody across is going to be the next step. Keep in mind and remember that when you need to multiply the electrons by 2, it has to be everything in the line, not just the electrons. So if your first half reaction is being multiplied by 2 and your second is being multiplied by 3 because you need them to be 6 electrons for common denominator's sake, every single chemical formula gets multiplied across. Once that is all matched up, I like to re-add all of my pieces. You can, at that point, like if you knew that you had 6 electrons on the product side and 6 electrons on the other side, you can cross those off. I have to see it all in one go because by this point my paper is usually so messy that I just can't determine it. So I shift all of the reactants to one side, all of the products to the other side, and then simplify. You're going to cross off anything that matches, even if it means you have 6 H2O molecules on one side and 5 on the other. You can eliminate the 5 completely and just be left with the 1. After that, your half reactions are completely added back together and you have something balanced in an acidic solution. If you are instructed to add something in a basic solution, you have one more step and you need to add hydroxide to balance each H plus molecule. Now, if you're told to balance something in a basic solution, but you can cross off all of your H pluses, you're going to be done regardless. So sometimes when you're doing balanced half reactions, you might have the same answer for acidic and basic solutions, and that's okay. It's just working down and making sure that you do all 8 steps for the acidic solution and then that 9th step for your basic solution.